Allison is a developer advocate for GPU-accelerated AI libraries, AI APIs, libraries and tools at NVIDIA with a specialization in advanced data science techniques and LLMs. She brings over 8 years of hands-on experience as a data scientist, focusing on managing and delivering end-to-end data science solutions. Allison also gave a 4-hour tutorial yesterday, so wonderful that you're giving a talk today as well, and appreciate everything you're doing here. Without further ado, put your hands together for Allison Ding.
Thank you, guys. Thank you, guys. So I'm very glad I have the opportunity to present on the Unlocking AI Performance with NeMo Curator, Scalable Data Processing for Large Language Models. Today, I will be presenting on an NVIDIA product called NeMo Curator on how to train the foundation model and fine-tune the foundation model. So before we dive in, let's first understand why we need data processing at scale from the data standpoint. So if you look at the image from the recent survey paper, back in 2007, the Common Crowd dataset was essentially the only large dataset widely available for research. And over the years, the amount of data needed for a large language model has grown significantly. Today, we not only have massive training corpus, we also have instruction tuning data, preference dataset, and evaluation dataset. After 2023, these datasets have continued to expand rapidly. To keep up, we need GPU-accelerated techniques so that data processing pipelines remain efficient and scalable alongside model growth. And before we dive in even further, another aspect I would like to highlight is the amount of data we are producing. So if you look at the image on the left-hand side, the amount of data we produce is growing exponentially into petabytes already. How much is a petabyte? There are like 15 zeros after one. We are producing an enormous amount of data. And because we have produced enormous amount of data, we have built very complex large language models that may have up to a few hundred of billions of parameters, as you can see in the middle. And from the graph on the right, you can see that we're still using libraries and frameworks that follows Moore's law, such as pandas to process the data, but Moore's law has ended as is no longer valid. Also, the downstream training or fine-tuning of the foundation model is already GPU accelerated and optimized, but the data processing step before training is not. That may eventually become a bottleneck for us. So if I categorize large language model training or fine-tuning, I can break it down into 3 main buckets, and including training the foundation model, fine-tuning the foundation model, and the RAG-based workflows. As for the training foundation model, the dataset size we need is in upper terabytes or lower petabytes, and we definitely need a supercomputer to do that. And how often are you to train a foundation model? Maybe once a while, right? For example, Llama 3.1, I forgot to mention, Llama 3.1 uses 15 trillions of tokens. As for the fine-tuning foundation model, it usually has a dataset size in gigabytes, and we need a single node to perform the task. And how frequent are we going to fine-tune a foundation model? Not daily, not weekly, maybe monthly. As for the RAG-based workflow, the dataset size we need is in gigabytes, and we need at least a single GPU to perform it. And we may do it iteratively and continuously. For the purpose of today's workshop, we will only focus on training foundation model. There are a lot of challenges with existing solutions for training the foundation model, especially when you are working on a CPU-based system. First, training takes significantly longer, increasing both time to market and compute cost. Second, you may not have an optimized models, leading to wasted resources and reduced accuracy. And thirdly, your pipelines may not be very optimized, as you may pull different modules and components from different libraries and put them together it may slow down your iterations and deployment. And the last but not least, you may need a deep expertise required to tune, scale, and optimize these workflows. All of this adds up to a higher TCO and delayed innovation. So what is the solution we provide? NeMo Curator. NeMo Curator is a scalable and configurable pipeline that helps curate text, image, and video datasets to power more accurate AI applications. It enables higher accuracy with less data and less training compute. The GPU acceleration with rapids for dedupe and quality classifier models is part of NeMo Curator as well. And talking about scalability, it can handle up to over 100 petabytes by scaling across multiple nodes. And we also have the state-of-the-art quality classifier NeMo microservice for safety, content, and diversity, and it can be deployed anywhere. And we are providing some links to the GitHub. The NeMo framework container, PyPI, and microservice interface is coming soon, as you can see at the bottom of this slide. And for the purpose of this workshop, because we only have 30 minutes, I will only focus on the text. But if you are interested in the image and the video training foundation model as well, you can come to me. I can share with you more contents. And high quality data processing will maximize the model performance. We have done an ablation study on 357 million parameter GPT model. And as you can see, when you go through the curation method, the overall accuracy has increased significantly. With the Unicode correction, we can see a 0.25% lift. And with the deduplication, we can see a 4.29% increase in the overall accuracy in total. And after quality filtering, you can see a 7.12% in the overall accuracy. So if we have a raw text of 8 petabytes, only 1% of the raw text data is curated in the end to train the foundation model, which is roughly 68 terabytes. So the tiny fraction, 1%, has to carry the weight of the entire model's learning. What does that suggest? A better data curation is leading to better model performance. That is why scalable, intelligent curation pipelines are so critical. Let me do an introduction on the NeMo Curator for text processing. NeMo Curator is an open source library on GitHub, available through pip install. There's also a container available on build.nvidia.com. In its design, we prioritize making it modular and GPU accelerated. And from the left to the right, we start with data download and extraction. Then afterwards, we clean and pre-process the data. Then afterwards, we do a heuristic quality filtering. And if you have the data scarcity issue, you can do a synthetic data generation. And afterwards, we do an exact value or semantic deduplications, and followed by model-based quality filtering, deduplication, PII removal, or task decontaminations. And if you look at the entire workflow, it's highly modular. You can swap every component in and out based on your use case. If you don't need synthetic data generation, you can exclude it. If you do not need quality filtering or deduplication, you can skip those steps. And if you have your own instruct or reward model, you can always swap them in. And under the hood is all supported by DAS and rapids, including cuDF, cuGraph, and cuML. Those are the 3 libraries of rapids. cuDF is the GPU-accelerated pandas data frame dealing with data operations. cuGraph is the GPU-accelerated graph analytics. And cuML is the GPU-accelerated scikit-learn. There are 3 main features of NeMo Curator to train the foundation model: the synthetic data generation, deduplication and classification, and GPU acceleration with rapids. First, synthetic data generation. We have provided pre-built pipelines for tasks like prompt generation, dialogue generation, and entity classification. It's been made modular and OpenAI compatible for the deduplication and classification. There are two levels you can perform the deduplication, the lexical deduplication and the semantic deduplication. And for the classification, we have built the state-of-the-art classifier models. The last piece is GPU acceleration with rapids. Like I said, we have been leveraging cuDF, cuML, and cuGraph under the hood. I'm going to talk about each feature in details. The first and the most important one could be synthetic data generation. I'm providing an example on this slide. As you walk through the SDJ process, the first thing you need is a seed document. Assume you are from a financial institution. You want to synthetically generate more data, and you want the generated data to speak the same language with yours, using the same jargons and same terminologies, so you may want to dump the model with a seed document. And the second thing is critique model. It can be a single large language model, can be a panel of large language model, can be a reward model, or can be a LLM agent. Then the last step is a filter. You may want to do deduplications based on your need. You may want to remove the PII, confidential information, and you may want to adjust the toxicity of your data. And you may also want to do some business domain classifiers. And afterwards, you will get a high quality synthetic data. We have provided some tooling support for synthetic data generations. From the prompt generation perspective, we have provided open QA, closed QA, writing, mass coding, dialogue generation, and entity classification. They are all available from the NeMo library. You can just import the functions. And the second piece is, second support is the Llama 3.1 NeMo 70B or 340B reward models. Those both are benchmark topping performance, especially 70B reward model. Currently, it ranks the highest on the leaderboard. 70B reward model will produce a single scalar score, as opposed to 340B reward model, which will produce multi-dimensional matrix scores. They are both available for commercial use. As for the tooling support, currently it has been integrated into the existing pipelines, and it's made highly modular, so you can bring your own instruct or reward model. You don't have to use NeMo NVIDIA's models. You can find models from Hugging Face. And it can support different filtering technique as well. I'm providing one example that uses prompt to synthetic generate the questions and answers and reward score on the Jupyter notebook. As you can see on the left-hand side, I'm using the NeMo 70B instruct model to synthetically generate some questions. And on the right-hand side, I'm using 70B reward model to calculate the reward score for the questions I just generated. And you can add your own normalization functions to normalize those single scalar scores. And I'm giving you another example. We can also build SDJ pipelines or packages to generate the data. So you can call the main function, your main Python script, and from there you can call the synthetic generators class with its functions, and it will get automatically executed for multiple runs. And for each run, the result will be automatically output to the respective folders. And at the bottom of this slide, I'm giving you an example on the SDJ curated result. This example is generated using 340B instruct and reward model. As you can see, at the bottom, it gives us a multi-dimensional scoring matrix, including helpfulness, correctness, coherence, complexity, and verbosity. Those are all evaluation metric for the synthetic generated data. And the next feature, before we jump into the next piece, I want to give you guys a demo on the synthetic data generation. Let me change the screen. So it automatically downloads the data from the URL. And because it already exists, so it's skipping the download. Then we are using the NeMo 17B instruct model for the synthetic data generations. So after the initial curation, the dataset has 12,000 records. It's been reduced from 19,000 records after the data cleaning and the semantic deduplication step. Then afterwards, it comes to round 1. It synthetically generated another 10 rows of 10 records. Then another round of semantic deduplication has been performed. So the dataset size dropped back to 12,000. I'm just showing you one round of SDJ, but if you want more round, you can add more rounds and eventually concatenate into the folder. Under the curated folder, under round 1, you can see the synthetically generated data. Okay, let's go back to our talk. So next feature of the NeMo Curator is deduplication and filtering. It has 2 types of deduplications, lexical deduplication and semantic deduplications. As for the lexical deduplications, you have it basically utilizes the text similarity to discover duplications, including exact deduplications and the fuzzy deduplications. For the fuzzy deduplications, we have been using some algorithms like min hash, bucketization, and clustering. As for the semantic deduplications, it utilizes the meaning of the text to discover duplicates. It leverages embedding models to identify the semantic documents. Let me give you an example on the example configuration file to perform the semantic dedupe. As you can see, the embedding we are currently using is a mini large language model. It's been made highly modular, so you don't have to use this model. You can use whatever model from Hugging Face. And we have made the clustering, number of clustering to be 1,000, and the similarity matrix to be cosine similarity, and some epsilon thresholds. Those are all adjustable based on your need. And as you can see, we go through the pipeline. After deduplication, the overall accuracy has been improved to 4.29%. And the last piece is classification and PII removal. For classification, we have domain classifier functions built in, so you can classify the text into 26 domain classes. As for the document quality classifier, you can basically categorize them into 3 buckets, high, medium, and low. As for the masking or PII removal, we currently do not have our own models. We are using the sparsity model from Microsoft. So again, we are showing you how modular it is. And after we gone through the classification and the PII removal step, the overall accuracy has been bumped to 7.12%. And 2 messages I'm trying to pass here. The first is by removing the low quality data, we can significantly improve the accuracy for the LLM downstream tasks. And from the scalability perspective, so basically when you are training the foundation model, you have a lot of data, you want to scale it to 8 GPUs or an H100 node. you can see a significant improvement in the processing time. And how simple or how hard it is to do, you can simply, like Keras, you can simply use a sequential model to design your own pipeline. And if you don't like unit reformatting, like Unicode correction functions, you can remove it. If you don't like word count filter, you can remove it. If you need this synthetic data generation, you can add it. Or if you need semantic deduplication, you can add it as well. It's very flexible. And there are some good resources we have to help you get started with NeMo Curator. We have also provided the tutorial and blogs on the pre-training or fine-tuning. And we have a very good developer program at NVIDIA. We publish a lot of technical contents. If you want to keep track what is the latest, what's going on in the data science ecosystem, or what is the latest technology we have developed, you can go to developer.nvidia.com and enroll in the program. You will receive all this information in the form of the newsletters. And also, by scanning the barcode at the bottom, you can get a free technical course. And thank you so much for coming to my talk today.
Thanks for such a wonderful talk, Allison. Feel free to ask questions in Slack, but for people in the room, if anyone has a question, yeah, I'll give you the microphone. So if you could introduce yourself, that'd be great.
That's fine. Hi, my name is LaFane Campbell. Work for Purina, machine learning engineer. For the fuzzy section for either decoupling or classification.
Sorry, I couldn't hear you.
Oh, I'm sorry. For the fuzzy part of the duplication and classification, are there parameters that you have to change in order to, is like a threshold or something that you have to do to make that work, or does it just work automatically?
Fuzzy deduplication actually original is as part of my talk, but since we have the time constraint, I'm not able to talk. It's not that simple. If I need to explain to you, I may explain to you, like spend 20 minutes. Yeah. So we can talk after this workshop, maybe.
Okay, and the Microsoft version for semantic classification, is that similar? Because you mentioned the fuzzy version of that also.
We currently have our own classifier models. Okay. And the only thing we borrow from Microsoft is the sparsity models. Okay. That's dealing with PII removal and masking.
Okay, all right, thanks.
Welcome.
Thank you. Any other questions? I have a question. I love how you talked about synthetic data, and I'm giving a talk next where I talk about using synthetic data to generate potential user queries in order to evaluate products before launch. But I'm wondering because I have a lot of concerns about synthetic data, but I'm wondering if there are any concerns that crop up in your line of work in using synthetic data.
The only thing I think I'm going to worry about is two concerns I have. The first is about the raw data set you are dumping in. If your raw data set is not of a good quality, if it has like a limited length, and even if you use it as a C document, you are not able to generate a good synthetic data. And the second concern is after your synthetic data generations, you may worry about the quality of the data you generate, right? So which critique model you should use to evaluate it is another like well-studied research they have been doing. You can use a single large language model. You can use a panel of them. You can use a reward. You can even use an agent. Here I'm introducing the NeMo 70B reward model, and it's currently the best one on the leaderboard to evaluate the data set. And oftentimes, I may get a negative score. So which indicates the data quality is not very good. But when we are doing the human annotations, we read it into it and we think the synthetic generated data is actually of good quality. So the reward model is actually giving us like a wrong direction, right? So how are we going to deal with it? We choose to use a normalized data. We use the normalization functions to convert the a single scholar score in between -1 and 1. So whatever is above 0 is considered as good. Whatever is below 0 is considered as bad. That's how we make the decision. I think, does it answer your question?
Yeah, that's super helpful. Thank you, Allison. Any other questions? All right, our friend in the front.
Thank you for this talk. My name is Tudor. I'm from Oak Ridge National Lab.
Great.
I would like to know if NeMo Curator would work with different type of data sets. And when I say different type, I meant in the same
Multimodality, right?
Sorry, what?
Multimodality.
No, they're all text, but I'm thinking a data set that can have multiple formats. A data set where you can have tabular data, you have PDFs, you can have tables, so multiple formatted data in the same data set. Would NeMo Curator would be able to identify, or would you do something else before you feed that to NeMo Curator?
This question, I believe we have some built-in functions to take care of the unstructured data. However, I think depends on your use case. You may need to have your own built-in functions, but always feel free to bring your own functions into the pipeline.
That makes sense. It helps. Thank you.
Thank you. So for some people, they may think that NeMo Curator pipeline is still too complicated. I write a lightweight curation pipeline in Jupyter Notebook. That is going to be published on the SciPy Proceeding paper. If you have less coding intensive background, just I feel like a lightweight model may suit your needs a little bit more.